In this video, we're going to run through a series of graphs, and it's going to be up to us to determine whether or not this represents a function, and then we're going to determine the domain in range. So first up, we have this little squiggly guy. Remember, to determine whether or not something's a function, use vertical line and do the vertical line test. So if we see this hitting more than one point at a single time, then this is not going to be a function, but you see as I go across, I only ever hit one point at a time. So what you have to watch out for are graphs that kind of curve back on themselves or that seem to be stacked on top of each other. So here we can say that yes, this is a function. And what about the domain? Alright, so your domain is the set of all x used to make up this picture. Well, you see that this guy goes all the way left, he goes all the way right without a break, so his domain will be all real numbers. Alright, what about the range? The range is the set of y values, and so for range, least to greatest means going from bottom to top. This guy goes all the way down, he goes up, comes down a little bit, but then he keeps on going up. So there are no breaks, no gaps as he goes from bottom to top, so his range is also going to be all real numbers. Now something that I tend to do on graphs like this is I try to connect everything to the x and the y axis so that I can identify the domain and range using interval notation. So here this guy's going down, and as I trace this guy, he is going up here, he comes back down, and then he keeps going and going and going. And so you see that I end up covering everything on the y-axis, which is why the range is all real numbers. Alright, example 1. Now example 2. Here is this crazy looking guy. Is this a function, yes or no? Well, as you come along here with your vertical line, everything's fine until you get here. And then you see that you are hitting two pieces of the graph every time this vertical line goes across. So no, this is not a function. So not a function. Well, what about the domain? Right? Even though it's not a function, it's still a relation, which means it has a domain. So let's check this out. If I were to do what I did on the last example for the range and do it for the domain, this piece right here starts at -5 and he goes all the way out to the right. This other piece also starts at -5 and goes all the way out to the right. So the domain is from bracket -5 to infinity. Okay? And you might say, yeah, but it's there twice. It is there twice, but look at what I colored. I just colored from -5 to infinity, right? We don't need to worry about repeats, right? As long as we are using it and we identify that we're using it, we're going to be fine. Now your range. This piece right here is going down. I know you may be thinking, oh, but he's going to the right toward positive infinity. But when it comes to range, range is an up-down movement. So he's coming from down, from negative infinity. This guy goes up to here, so he goes up to -2, and then there's a jump, and it comes back here at 4, and it just goes all the way up. So you see the pink that we've graphed on the y-axis, and that tells us our range. We just now need to translate that using interval notation. So least to greatest, from negative infinity up to, this was -2, bracket, union, because we have to join this with the other piece, so that's bracket for all the way up to infinity. Alright, so we had that jump, we had that gap, so we have to use that union symbol to connect those two sections together. Now let's look at this one. Is this graph of a vertical line something that passes the vertical line test? Well, everything's fine until you get right here. then all of a sudden this vertical line test is hitting every part of the vertical line itself. So it fails miserably, the vertical line test. So this is not a function. So what about the domain? Let's see. Notice that with this vertical line, you're not going to the left, you're not going to the right. You are stuck right here at an x value of 6. So the way that we denote that we're just including 6 and that's it is by using set builder notation, so using the curly brackets like that. So we are only including 6. It's not from 6 to anything else, it's just the element 6, nothing else. What about your range? Well, let's see, is your range the same thing? Well, notice this guy goes all the way down and he goes all the way up. So in terms of the range, he's covering a lot more. He's covering everything. So that's from negative infinity to infinity. So you got to watch out for things like that. For vertical or horizontal lines, their domain and range may be just a single element like that. All right. One last guy for this video. We've got this oscillating wave. First of all, let's see if this is a function. Now, sometimes it's kind of tricky and you think, oh, it's not a function. Well, if it's not a function, then you should be able to draw a vertical line that's going to hit this graph in more than one spot. But you see, as we go along here, I only ever hit this graph one point at a time. So this guy does pass the vertical line test. So yes, this is a function. Well, what about the domain? Remember, the domain is left to right. This guy goes to the left, and he's bouncing all the way from the left, all the way to the right. So the domain is all real numbers. And what about the range? Does the range do the same thing? Well, notice that this guy bottoms out right here at -1. He bounces up to +7. Then he comes back down to -1, up to +7, down to -1, and he keeps doing this back and forth motion. On the edge here, you see that it looks like it's going to still continue that same pattern. If it were anything that were all of a sudden going to be shooting off to positive or negative infinity, the graph would be very clear about that. But you can see there's consistent behavior for this graph, that he is sticking between -1 and +7. And he's not going beyond that at all. So, there you go. There's the range. Nice and easy, right? Love doing these guys.